Guys, how are you? I hope you are all doing well. This is my first YouTube lecture on heat transfer subject. Heat transfer subject is a core branch of engineering subject for mechanical engineering, chemical engineering as well as aerospace and cryogenic engineering. Let's coming to the topics.
In this class, I will explain about introduction to heat transfer, differences between thermodynamics and heat transfer, applications of heat transfer, fundamental laws of heat transfer. Introduction to heat transfer. What is meant by heat transfer? Heat means a form of energy. Heat is a form of energy. It is measured in joules. Transfer means movement of certain quantities due to interaction of system with its surroundings. Movement of certain quantities due to interaction of system with its surroundings is known as transfer. Next, driving force. What is meant by driving force? Heat is transferred from a body to another body first condition is temperature difference. Then only heat will transfer from high temperature body to the low temperature body. Here T1 is the high temperature body, T2 is the low temperature body. Heat is transferred from this high temperature body to the low temperature body because of the temperature difference only. That is the driving force for the heat transfer. Next, transport process. Driving potential. Heat transfer driving potential, temperature gradient, momentum transfer, velocity gradient, mass transfer, concentration gradient. Next, differences between heat transfer and thermodynamics. Heat transfer and thermodynamics both are basic science subjects. What is the need for a separate science of heat transfer is needed? In thermodynamics subject, describes about interactions of heat and work, how the heat is converted into work and how work is converted into heat. Next, laws of thermodynamics. Thermodynamics describes about laws of thermodynamics. First law of thermodynamics discussed about law of conservation of energy. gives energy balances. Second law of thermodynamics describes heat flow direction. Heat always flows from high temperature to low temperature body. Next, third one, thermodynamics deals with equilibrium processes. A thermodynamic process is completed. In that process, total heat transferred in that process is given by laws of thermodynamics. Heat is measured in joules, but rate of heat flow cannot be determined. Next, temperature variation with time and position cannot be calculated in thermodynamic subject. Rate of heat flow, temperature variation with time and position cannot be calculated in thermodynamic subject. That's why separate science of heat transfer is needed. Heat transfer subject deals with rate of heat transfer. How much heat is flow per unit time is to be determined by using rate equations. Second, temperature distribution. Nothing but temperature profile in that body during the heat transfer is to be determined. Third one, mode of heat transfer. In which mode heat is transferred from one body to another body is also determined by using rate equations. That is the major differences between thermodynamics and heat transfer. Next topic, applications of heat transfer. Heat transfer is number of applications in different fields of engineering. First one, mechanical engineering. Heat transfer applications are boilers, heat exchangers, turbine system, IC engines, refrigeration and air conditioning, etc. Metallurgical engineering also heat transfer applications are there. Those are furnaces, heat treatment components. Electrical engineering heat transfer applications are cooling systems for electric motors, generators and transformers. Chemical engineering heat transfer applications are oil refineries, chemical plants. Nuclear engineering also heat transfer applications are removal heat generated by nuclear fission using liquid metal coolants. Liquid metals are mercury. Next, aerospace engineering and space technology heat transfer applications are aircraft systems and components. Cryogenic engineering heat transfer applications are storage and transportation and utilization of cryogenic liquids. Cryogenic liquids means those liquids are at very low temperatures, -°C. Those type of liquids carrying from one place to another is very difficult. In that case, this heat transfer applications are very important. Next, civil engineering. In civil engineering, heat transfer applications are railway tracks, air conditioning and insulation of buildings. Those are the different types of heat transfer applications in many fields of engineering. Heat transfer has a wide range of applications. Next topic, fundamental laws of heat transfer. These are the laws related to heat transfer. First law of thermodynamics gives the conservation of energy. Second law of thermodynamics, which gives the direction of heat flow, in which direction heat is flow. Generally heat is flow from high temperature body to the low temperature body. These two laws are described in thermodynamic subject. Equation of continuity gives the conservation of mass. Equation of flow, Newton's second law of motion. These two laws are used in convective heat transfer. Next, rate equations governing. These are the governing equations for heat transfer. Those are the three modes of heat transfer: conduction, convection and radiation. Conduction mode of heat transfer is governed by Fourier law of heat conduction. Convective heat transfer is governed by Newton's law of cooling. Radiation heat transfer is governed by Stephen Boltzmann's law. These three modes of heat transfer we can discuss in next class. These are the fundamental laws of heat transfer.
Thank you guys. Thank you for your patience listening.